Welcome students, today we will discuss the ray optics topic, displacement method. This method is generally useful to find out the focal length of a convex lens or a plano convex lens, okay, and it is not applicable for the concave lenses or any other lenses, okay. So we are going to have that explanation today, that is displacement method. In this method actually there will be a convex lens whose focal length we have to find, and there will be one real object and a screen. The distance between the real object and screen is generally fixed, okay. So I am taking, this is the screen, okay, and this is going to be the real object. In between the screen and real object the distance is capital D, and we are placing the convex lens over here, right. The focal length of convex lens is f, and definitely it will form an image on the screen. Depending on this object distance, it will form an image. Let this be the I1 first image, and of course this is the focus that you know very well, and this is the object distance, and corresponding image distance is going to be this one, okay. But what we can write here is v plus u equals to d, because the total distance is fixed, and we can rewrite this v equals to d minus u, and if you substitute in the lens equation 1 by v minus 1 by u equals to 1 by f with sign convention, it will become 1 by v plus 1 by u equals to 1 by f, because I have to take the negative object distance for the real object, okay. And I can substitute v as d plus u, and I can rewrite this equation 1 by d plus u, sorry, it is going to be d minus u, okay. So d minus u plus 1 by u equals to 1 by f. Thus me solving this, you will get an equation. That equation is going to be, it is u square minus du plus df equals to 0, okay. So this is the important equation. The solutions of this equation will be calculated by the discriminator method, that is minus b plus or minus under root of b square minus 4ac by 2a, okay. And it will have, if you substitute in this formula, this equation, these parameters, if you substitute there, you will get here a is 1, b is minus d, c is plus df, okay. So we can write that u equals to d plus or minus under root of d square minus 4df whole divided by 2, and this is a case you can have. Suppose actually there are three possibilities here you can have. Suppose you have that d is less than 4f, okay. If d is less than 4f, okay, then this is going to be a negative number. I mean, it is going to be a complex number, okay. It is the imaginary part, imaginary plus real is going to be complex number, okay. So in general it is not existing, so it will not exist in real world because it is going to be imaginary number, okay. When distance between the screen and object is less than 4f, okay. Suppose if d equals to 4f, where f is the focal length of the lens that we need to find. If d equals to 4f, as you can see here, d square, like 4f square minus 4f square will come here again, so it will be 0. So u will be equals to d by 2, okay. Only one position is possible here, only one position for the lens is possible. So if only one position is there for the lens, then the displacement method cannot be applied, okay. So to apply the displacement method and to find the focal length, at least we need two different positions for the lens, so that two real images are formed on the screen, and that will happen in case of this case, that is when d is greater than 4f. Then it will have two cases. They are like u1, when you take d minus under root of d square minus 4f d by 2, that is d minus under root of d square minus 4f d by 2, that is u1. Corresponding v1 will be there, which is d minus u1, okay. And u2 will be d plus under root of d square minus 4fd by 2, and corresponding v2 will be there, which we can write d minus u2. Okay, so we can find the, we just found out that u1 and u2. So I'll draw the diagram in the next board. I hope you got it. So if I draw the diagram for this case, it is going to be, if this is a lens position u1, then as I have already shown in first case, it will form a real image. It should be a straight line. This is I1, this is the focus of course, and when you displace this lens to some other position, this is actually u1, and this distance is going to be v1. Now you displace this lens from here to somewhere here. Let me draw with black color that. And the same light ray you have to extend, and it may reach over here. Okay, so this is going to be I2. As you can see here, the I1 is enlarged, I2 is diminished. Okay, if the lens is close to the object, generally image will be formed enlarged. If lens is far away, generally if it is going away from the object, then the image formed will be diminished. So there are such images actually, I1 and I2. Now corresponding, this is going to be U2, and this is going to be V2. There is a relation between all these actually. Okay, that relation I have already proven. I'll give you that. The relation is very simple. The image distance in first case equals to object distance in second case, and the image distance in second case equals to object distance in first case. You can use these two equations to prove this. Okay, and these are important